Hello and welcome to another video. In this problem, we're going to be doing the second problem of the weekly contest for Saturday, and this is going to be double modular exponentiation. And in the problem, you're given a zero index 2D array of variables, where variables has these four fields, A, B, C, and M, and a target. And an index is good if the following formula is holds, A to the B mod 10 to the C mod M is target. So to show you these examples and what these values equal, so for example, this first array 2 to the 3 mod 10 to the 3 mod 10 is 2, which is the target. The second one is not, and the third one is, so we return the indices. And in the second one, there's only one index, and this whole thing is 1, and the target is 17. So essentially, if you take four variables, let's just say A, B, C, M, and you have A to the B, and the rest of it is mod 10 to the C mod something M. This is actually pretty easy to do because you can actually, especially in Python, even if you do something like some number to the 1000, this is going to get really big and it's going to cause an overflow in most languages. But in Python, there is no overflow. So you can actually even, you can basically calculate this exactly, right? So this will give you some super huge number, and it actually won't take that long because modular, or not modular, if you want to do A to the B, this actually is in log B time. So log 1000 is like 10. So what'll happen is this will be in roughly 10 operations, let's say, and then we'll mod it by 10, so it'll be a really small number, and then we'll do this, and that'll be roughly in 10 operations again. So it'll be something like 20n or something, Obviously, not exactly, but something like that, which would just be O of n. So even though we're making something go to a huge power, it doesn't really matter. Now, let's say you are doing it in a language that overflows. I think C++ actually has a function that handles this, and so does Python. You have a power function. Instead of doing 2 to the 1000 like this, you can do something like this. You can do power, and then it's going to take a base, an exponent, and then a mod value. And what this does under the hood is it keeps your values small. And this is actually very easy to do if you know modular arithmetic. So let's say we want to do 2 to the 1000, or whatever. Yeah, let's say we want to do 2 to the 1000, mod 10. So the way this works, or the way you can write it, is first of all, you can keep breaking it down. You can either recurse or just have some kind of iterative thing. So this will be 2 to the 500 squared, right? And then this is going to be 2 to the 250 to the 4th. So you just keep recursing, and you just keep multiplying your result by the other result. So you keep doing that, you keep doing that, you keep doing that. And then as you start multiplying, it's easy to keep the number small because with modular arithmetic, you can mod at any time you want. So you can calculate 2 to the, let's say 20 or whatever you want, and then mod 10, right? And so on. So you can actually just as you keep increasing the number, before you increase the number, you can just mod it by 10. So 2 to the 20 mod 10, let's say we do 2 to the 10, for example. So I think 2 to the 10 is something like 1024, I want to say. So mod 10, this should be 4, right? So let's just say we do this in chunks. Hopefully 2 to 10 is 1024, but we'll see. So let's say we do this in chunks. Let's say we calculate, for example, 2 to the 4. So 2 to the 4 is 16. So let's say we do 2 to the 4 times 2 to the 4 times 2 squared. So 2 to the 4 is 16. Mod 10 is going to be 6. So this is 6. And like I said, with modular arithmetic, when you multiply a bunch of numbers, if you multiply A times B times C, and this is mod some number, mod 10, you can actually take the mods of any of these anytime you want, and it'll be the same thing. So you can do well, let me maybe do A mod 10, and then maybe multiply that by B, and then multiply that by C mod 10, whatever I want. I can mod 10 anytime I want, as long as I mod 10 the final result. So with this 16 mod 10, we would get 6, and here we would also get 6, so we'd get 6 and 6. Maybe we multiply these together, get 36, and once again, we can mod 10 anytime we want, so we can mod 10 here, we get 6, multiply by 4, get 24, mod 10 is 4. And so that's kind of if you had to write your own power function, this is what you would use. You would first take your power and keep dividing it by 2, and like recursing, you know, so if you wanted 2 to the 8th, you would calculate like 2 to the 4th, square that, and so on. So that would give you logarithmic time to complexity for your power. Because if you want 2 to 1,000, you can't just be like, okay, let me do 2 times 2 times 2 times 2, because that would be linear time. And the other thing is this modular arithmetic, where you just keep modding by 10 anytime your number gets big to make it smaller. And this is what power actually does under the hood. So in Python, you can actually just do this if you want to keep your number small, but this will technically, you can also just write like a to the 1,000. This will technically work because there's no overflow. And yeah, I think in C++ there's also this power method provided. So this is what we're going to be using. Essentially, all we need to do is, for example, like here, we can just say, okay, well, for this, so we need a to the b. So a to the b is going to be, we're going to use this power. So a to the b is going to be like, let's look for this first one. So it's going to be 2 to the 3, and then it's going to need to be mod 10. So we'll provide a mod value 10. And then whatever that result is, we'll have another power. So this is going to calculate a to the b mod 10. Then we need to actually make that to the power c mod 10. So we could have another power here. So take the first one, and then take the result of that expression, go to the c. So c is 3 in this case, and then mod m, which is 10 in this case. So you can actually just calculate this number, and then just check if it equals target. So you can actually just have like an O of n solution here. Yeah, because this should be really fast. Because like our array is only 100 numbers. Basically doing this, I guess it's not O of n. Sorry, this is a log n, but it's basically O of n because your powers can only get to like 1,000. So like I said, and because the numbers are kept small, you're not going to have any kind of overflow. So basically, your limits are b and c, which is just like I said, like 1,000 and 1,000, which is log of that is like 10 and 10. So that's super fast. So yeah, all we need to really do is just go through these, have an equation that calculates that whole thing, check compared to the target, and that's it. So, but I did want to share, if you did want to make it on your own, this is roughly what you would do. Okay. So here are the equation, just so we can see it. So we can actually do this in a list comprehension. So we can say something like return a list of I for, and then it's going to be I, and then the value we're just going to break down into this A, B, C, M thing. So A, B, C, M, in enumerate variables, and then we just need our condition. We can have this condition of this whole thing being target. So what we want to say is we want to say power of this internal thing is a to the b mod 10, so a b 10, and then the thing outside of that is going to be power again, and that's going to be like we calculated this part. Now we need this part to the c mod m, so it's going to be c m. And if this whole thing equals target, then we want to include the index, right? So we're essentially just including the index in all of this and calculating it for every single one. So we can run that. Oh yeah, I just needed that to see the equation. Let's take a look what our error is. Variables. Okay. And there we go. And these are kind of like similar for most people, so it's going to be super fast regardless of what you do. So this is basically, I'm just going to say it is O of n, even though it's technically, like I said, it's technically logarithmic based on the power of this b and the c. So if you wanted to be technical, you could say like it's going to be like O of n times log b, something like this, plus log c, I believe. So that would also be pretty reasonable. Yeah, I'm just going to leave it as O of n because for most people, when they review exponents, they just treat it as O of n. But yeah, you can actually, like I said, and I can even show you here, we could actually print like 2 to the 1,000 in Python, and this would totally be fine. So if you see here, here it is. Even though this would be an overflow in most languages. So just something to let you know, so you don't even need this power thing, you can just use a normal exponent in Python. Yeah, and then space is going to be O of 1 because we just have this return array. So pretty easy one for a second problem of LeetCode contest. So, but still good to be introduced to modular arithmetic and power. So hopefully this is helpful. If it was, please like the video and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.